Good morning, everyone. Thank you for being here on this special occasion for a talk by Professor John Mitchell, Distinguished Professor of Science University and Chair of Computer Science at Stanford. We are very sorry about the delay, but there has been some unprecedented traffic, so I'm glad you all came today. Special thanks to the educators who've turned up. I know it's a very, very busy season with the board exams being early this year. So thank you so much for the effort, and thank you for the journalists and other dignitaries who've turned up. Let me first start by introducing our first guest, Dr. Bhavani Shankar Subramaniam. He is the Director Strategy at Lalaji Memorial International School, Omega International School. So he has been very experienced in the education sector and has built many institutions. He is a very, very experienced person in the K-12 education sector, and he comes with research and management qualifications, teaching and training certifications, and is a keen leader to bring about change in the education industry. He is also the chairperson of Chennai Sahodaya, our collaborators for this event, which is an association of about 300 schools in the greater Chennai area, CBSE schools. So without further ado, sir, please, a few words.
Thank you so much. So it gives us this wonderful opportunity to interact with all of you. I represent the Chennai Sahodaya Schools complex today. This is a body that comes together to build cooperative partnerships among schools. And although the banner says that it is an affiliate body of the CBSE schools, in the larger scheme of things, it's a body that tries to connect and partner with schools to exchange ideas and exchange the learning and builds the environment of learning together. So thank you so very much, Dr. Barucha, Ramani sir, Sai University for giving us this opportunity to connect with all of you. And I would love that the students who are already enrolled in Sai University take this information to schools across. And through these partnerships, this gives us an immense opportunity to build the connectivity and network with Sai University. And through this particular opportunity, it's our desire that we strengthen this bond and network better with Sai University. I was also told that, say, I would have the honor of introducing Dr. Barucha here. So if I may use this platform, I would like to talk a little bit about Dr. Barucha. Say, I understand from Ramani sir and also from Sri Rajesh Rathod, who happens to be the chairperson of our school, that they have worked very closely together. And having come here, I also met with a lot of friends of mine. So Professor Subbarav here, so Akila Ramnarayan, and Maya I've just met today this morning, so thank you. So it gives us an opportunity to connect once again. And Dr. Jamshid Barucha, the founding Vice Chancellor of Sai University, is the President Emeritus of Cooper Union, New York. His previous positions include Provost and Senior Vice President, Tufts University, Dean of the School of Arts and Science, Dartmouth College, Fellow Center for Advanced Study in the Behavioral Sciences, Stanford University, and Visiting Scholar at Harvard University, Stanford University, and Carnegie Mellon Universities. He has done extensive research in cognitive psychology and neuroscience, focusing on cognitive and neural bases of perception of music. He was the editor of the Interdisciplinary Journal of Music Perception. Dr. Barucha is a Pride of America honorary accorded by the Carnegie Corporation of New York. He is a recipient of the Distinguished Achievement Award by the alumni and the alumni of the Vassar College and the Huntington Teaching Award by the Dartmouth College. He completed his PhD in psychology at Harvard University. He is also an alumnus of Yale University, Vassar College, and the Trinity College of London. So thank you, sir. I've had the honor of listening to him last year when the IC3 conducted its regional forum. And to have the vision that Ramani sir has and to build a university for liberal education is a wonderful concept. This morning, Dr. Maya picked my brains to find out what I thought about liberal education. I think it's the best way forward. So rather than pocketing all of us into clusters of what we ought to do with respect to STEM education and getting very myopic understanding of where we are headed as we complete our schooling and get on to the transitional spaces, most of us leave our students very confused about the options and the possibilities that they have for undergrad education and to shape their understanding in their careers. So Sai University and universities such as Sai University, which focus on liberal education, opens immense possibilities for us to scale the opportunities. We never had those opportunities when we grew up, and the journey of learning happened well into my 50s. So now you have this wonderful platform. I think the students should be the best ambassadors to carry this information forward and to share this amongst your peers to say that liberal education is the best way forward. So this gives all of us immense opportunities to understand the interconnectedness of things and simply the interdisciplinarity of all that exists in the learning continuum. And God bless all of you. And thank you so very much for giving this opportunity, and let me exploit this space once again to possibly open up possibilities for us to connect better with the Chennai Sahodiyas and a larger schooling environment. And I am very keen to listen to Mitchell's lecture now, and thank you. Thank you for giving this opportunity once again. God bless us all.
We now have the Vice Chancellor, Dr. Barucha, to speak a few words.
Thank you, Dr. Bhavani Shankar. We look forward to a productive partnership with your organization. While he read some aspects of my bio, I always think that the most interesting thing about people you meet is something that might not be on their bio. So what I learned today about Dr. Bhavani Shankar's bio is that he is a spin bowler. And he played for Madras University. Long back, but how many wickets did you take?
Very few.
Okay, so I look forward to someday bowl to me in the nets and be kind and teach me a few things, but because that is also interdisciplinary. Liberal education means trying to become the best version of yourself. And as some of you know, some of our students know, we have also admitted students. We have admitted students, obviously, who are academically strong. We've admitted students who might have achieved in other areas as well, extracurricular areas, be it music or dance or sports, because all the evidence from my field, which is an empirical study of human talent, cognitive neuroscience, shows that when people have put in the time and the energy and the effort and the discipline to master something, it carries over to other aspects of life. Okay? Liberal education at its heart is not about shoving knowledge down the throats of students. It's not about cramming. It's about each and every child, giving that child a chance to find what makes them tick, what their passion is, and then giving them the opportunity to develop those passions and to connect their multiple dots. The multiple dots is important also for liberal education because what we call subjects, which are often called disciplines, were ways in which knowledge was sliced in the 19th century. Okay, and there's an overwhelming view now that the space of human knowledge has expanded so greatly, those slices are no longer adequate. They're still important. History, chemistry, so on. But the spaces between those slices are infinitely dense. And if you look at Nobel Prizes in the last few decades, you look at some of the biggest breakthroughs in science, in the arts, in many fields, the social sciences, certainly in my field, cognitive neuroscience, which is inherently interdisciplinary, or you look at the development of applications of technology, okay? Most of the big breakthroughs have come from some visionary connecting dots from different subjects, okay? I'm not saying that's the only opportunity, but that's huge and it's infinite. And that brings us to the focus of today, computer science applied to arts, sciences, humanities, and law. Why such a title? How absurd to think that computer science has anything to do with the arts or the humanities or law. We know it has something to do with the sciences. But I want to remind you of stories you all know about some of the great innovators and entrepreneurs. Steve Jobs, like him or hate him, Apple, like it or hate it, completely changed the world. Now, he built the most successful computer company in history. And even if you don't use an Apple or you don't use a Macintosh, I guarantee every single one of you is using a user interface of icons and menus and dragging and selecting with your fingers or with a mouse, that was innovated by Apple. Now, they didn't invent it. It was invented, all of this, most of this was invented by Xerox, right down the street from Stanford at the Palo Alto Research Center. But in the infinite wisdom of Xerox managers, they looked at all of these things that were invented there. Almost all of this was invented at Xerox Palo Alto Labs, and the manager said, what is this? Useless. Useless. Dragging, selecting, icons, menus, it's for children, okay? And they allowed this 22-year-old crazy guy, Steve Jobs, to come in and look and take it all. Now, you all know the stories of people dismissing the applications of computing or data in new ways. Lots and lots of books written about this. IBM, I remember, and Mr. Ramani, who worked for IBM, I actually worked as a programmer one summer for IBM, just before their downfall. I remember when IBM was so big, the saying was, the United States economy will collapse before IBM does. That's how dominant they were. And they said very, very authoritatively that there would be no need for personal computers. No need for personal computers. A small number of very powerful mainframes around the world is all the world would ever need. Am I right or wrong?
Yeah, absolutely.
Well, look what happened to them. I'm sorry, apologies to my faculty, but disciplinary experts don't always get it right. Because we, and I was trained also in, disciplines. You get your PhD, it's don't always see the dots connected across different disciplines. When Steve Jobs was asked, what was the course in college, undergraduate course, that had the greatest impact on your creation of Apple? Did he say programming, coding? No. Did he say computer science? No. Of course, he loved computers. He was a tinkerer and he could code very well. What did he say? Does anybody know? Graphic design. Sitting and making fancy letters like an artist. How many of you remember that scene from the movie 1983 where this cricketer, Shrikant, is talking about how Kapil Dev was predicting that they could beat the West Indies, and everybody said, Pagal, Pagal. That's what they said about Steve Jobs, and I remember when the Macintosh came out, it's a toy. It's a toy, okay, give it to children, they can play with the mouse. What is this mouse? Look what happened. The CEO of a top Wall Street investment bank stated in the Wall Street Journal very authoritatively that people would never, individual investors, would never trade online. They would always want to pick up the phone and call their stockbroker. He had to eat his words. The music recording industry has been completely destroyed because anybody can create digital music. So the future doesn't belong to those who have mugged up the knowledge we have now. Of course, you have to have that knowledge in order to know enough to see the future. But the future lies, and it doesn't lie, frankly, with our generation. It lies with you, the students and the teachers from the high schools, the leaders of the high school association. This is the space into which a university like SCI comes in. Okay, and I think we have extraordinary opportunity because India has a high value of education, has the largest youth population in the world. But frankly, the youth has been very, very poorly served by the higher education establishment, terribly served by the higher education establishment. I'm actually writing an article right now for a volume being edited by Howard Gardner on international education about some of these things. Howard Gardner, who is one of the sort of gurus about education, I think most of the high school teachers would know about his work, says the purpose of a college education is to create and amplify intellectual capital, to attend, analyze, reflect, and communicate on issues of importance. That's what it is. Okay? It's not about shoving knowledge down your throats. And the two important elements of what he calls intellectual capital, the two most powerful elements that have most recently in history revolutionized our professional and personal lives, are computation and data analytics, which used to be the purview of only specialists, but now we rely on it all the time, and we all have tools that we can use these things. So what does this have to do with the arts, sciences? Well, sciences, it's obvious what the connection is, computing, but what does it have to do with the arts, humanities, and law? The kinds of dot connecting that Steve Jobs and others have done is still waiting for you and you and you and you to do it. Okay? Whether you do it working for a company, whether you do it as an entrepreneur, whether you do it as growing up to become a professor, whether you do it in some other capacity. You could be a lawyer, you could be working for a law firm, but because you heard that there's a future in enhancing computing and data science in law, you could transform the profession as well. Because computing is not just about coding in C++ or Java or the languages will come and go. And I hope that Professor Mitchell, who's written landmark books on computer languages, would agree it's fundamentally about the ability to solve problems in effective ways, which forces you to think clearly, and that can be applied to any field. And data analytics is the ability to access and make sense of information. It's not just something that geeks and nerds who love, data crunching do. Data is everywhere. It's in the arts, it's in music, it's in the visual arts, it's in the humanities, certainly in law. And so we crafted this title to try to get high school educators and high school students to think about a future that doesn't exist yet. Okay? It is standardly accepted now in higher education leadership circles in India. Every conference I go to, people say, you are the first generation, the young undergraduates or high school students, who will have to retrain yourself at least 3 times in the course of your career. Okay? What you learn and get graded for in college will be obsolete very quickly. And those of you who will be successful and be able to continue succeeding will be the ones who have developed the fundamental cognitive skills of relearning, unlearning, relearning, and embracing new things. So in the areas of computation and data analytics, there'll be very, very rapid developments. And those of you who understand the fundamentals will be able to grab onto the specific languages as they come and go. Now, I joined our distinguished founder and Chancellor, Mr. K.V. Ramani, with the promise of entering into this space, being a leader in Indian higher education, in showing that there can be a different kind of education that the economy is hungry for, because the economy based on new ideas, not existing ideas, that will give this huge youth population in India opportunities throughout their lives. If we teach them, you know, the old adage, you give somebody a fish, they'll eat that day. You teach them how to fish, they'll eat forever. That's what we want to do with you. And computing and data science apply to all these disciplines. Mr. Ramani is an entrepreneur who has had massive impact, the way many have in the computing world. He entered the software industry at a time when India was nowhere. Nowhere. So it took a vision. I'm sure a lot of people said, "What are you doing, sir? What is this computer?" I know from Mr. Sriram Panchu, very distinguished lawyer, who is on our governing board, who was really the pioneer of mediation and arbitration in Indian law. When they were young men, I said, "How did you come to know Mr. Ramani?" He said, "Well, he was trying to import a computer, a mini computer, was it? And he couldn't get the damn government to let him import the thing. Okay? And apparently it had been shipped. It was sitting in some godown in Delhi or something like that. And he simply could not get it released. I remember once trying to bring a Macintosh into India, and at the airport they took the whole thing apart and made me write down everything. And then I said, "Mouse." He said, "Mouse, chua kya hai?" Okay? So he couldn't even bring that in. Eventually, they managed to get it in. But that's what being a visionary is. You don't let the bureaucrats have the last word. And I think in the creation of Sai University, some of you know, I'm brutally honest. It's a huge character flaw. But in building Sai University, everybody who's at Sai knows, if somebody says, "Arey sir, this is how it's done in India," then I say, "I don't want to listen to you. I don't want to listen to you." Okay? Nonsense. We want to achieve more than that. And also that's what a liberal education will teach you all to do. Mr. Ramani was a leader of that kind. And through extremely hard work, you know how much energy he has, and commitment and selflessness, built a software empire, entering the industry at a time when India was nowhere. And he, with others, Narayan Murthy and others who entered at that time, made India the software export nation of the world. And then, having sold his companies, instead of just living the life of the riches, or displaying it, he has given it in philanthropy with no expectation of financial return. And that's what certainly persuaded me to join and start a liberal university with an unique international flavor, and to transform the lives of students who are looking for a different kind of university in India that can bring forth all of their talents. Mr. Ramani, you know many aspects of his biography as well, but he was a co-founder of NASSCOM, which was instrumental in getting the government of India, the bureaucrats, to back off and persuading them that India could in fact be successful in this area, and bringing all of the leaders in the software industry together. He has given scholarships to poor students for decades, and he has given grants to hospitals and medical institutions for medical care, again, with no expectation of financial return. And I think he also is a cricket player. With that, please welcome Mr. K.V. Raman.
Good morning, dear friends. Thank you, Jamshed, for your very kind and generous introduction. And first of all, I want to say that we apologize for this Indian Standard Time delay, which is caused by enormous traffic outages en route. But I do believe some of our guests online have kind of logged off. I request them to log back in because the excitement is just about to begin. So after me, Professor Mitchell is going to talk, and I'm sure that none of you would want to miss that speech. Before I proceed to say what I wanted to say, Jamshed has triggered my thoughts in a completely different direction, so I'm going to react and add on to a few of what he said about the evolution of Apple and computers in this world. A few things that I know personally. Third is that IBM never took PC seriously, that's for sure. They thought they were toys. They thought that mainframe computers were the only way to go, and I'm sure Professor Mitchell has seen it all. We found out yesterday that we belong to the punch card generation, which was like, approximately 50 years ago. And it's ancient history for many of our students here. The key is that IBM lost the game on personal computer, wanted to catch up, tied up with contract manufacturers to bring PCs to this. And then they didn't have an operating system. The part of the story that want to continue from where Jamshed left, they contacted in those days the first digital operating system for PCs was called DR-DOS, Digital Research DOS, which was founded by a company by name Mr. Philip Khan, person of Pakistani origin who settled in California. Extremely successful entrepreneur, but he was so high in his success that if an IBM call, he was taking a joyride in his plane and didn't respond to IBM. And therefore IBM said it's very hard to do business with someone like this. And they went to Bill Gates. And Bill Gates was in a garage. So they signed up with Bill Gates to create a parallel operating system which is called MS-DOS, as we know, Microsoft DOS. The wisest thing that Bill Gates did was a combination of not only computer science, but his knowledge of business and law. He pioneered the concept of software licensing. He didn't sell his MS-DOS to IBM for a few $1 million and then buy a plane and have a jolly ride. Instead, he licensed it to IBM on a royalty basis for every PC that IBM sold worldwide. And now the rest is history. And Microsoft, after that, were not the original inventors of all the other tools that we use today. Most of us know the first word processing software was not MS Word. First spreadsheet was VisiCalc. Microsoft adapted and brought it to market with their power. Same the case with PowerPoint. So they used the marketing muscle after making a successful company to bring adaptations of other companies' products to market to build a giant enterprise that what we know today as Microsoft. Hats off to them. At the same time, there are a few others who missed the opportunities. As Professor Bharucha rightly said, Apple grabbed the iconic design from Xerox Palo Alto Labs, where it was used as a user interface in their copier machines. And they did take it beyond. And Apple was the first to use it on phone devices. But where did Apple start? If you look back, Apple gained on someone else's failure. Sony dropped the ball. I don't know how many of you know the original Walkman was invented by Sony, which used to have a cassette inside, portable music player, and you put on a headphone and then you put in a pocket your Walkman and you listen to it. I can see a few people nodding your heads. And then it went on from there to Walkman to Discman. They replaced the cassette by a small disc, micro disc. It was a huge invention, step forward for Sony. And then they stopped the evolution of their product. And that was Apple's gain. Because Apple didn't start, as you know, with the phone first. They start with a music, portable music player, iPod, with an iconic interface, so that the music was available in semiconductor devices and you could carry it along with you and as a portable music player, which was later converted to a phone. So what Sony lost, Apple gained. And when they found an opportunity to enter a phone marketplace, they added a phone to it with a user interface from Xerox, and then today it is doing almost everything except cooking in your kitchen. Same way, I have come across several other situations in leaders and businesses. Many of you may not know that networking, as we know today, was invented in California and Stanford. As you know, it was actually designed to make interconnecting of computers within the Stanford departments. They won't talk to each other between computers of different manufacturers. So the researchers there wrote some software to connect the computers and make them talk to each other. And that's when the concept of networking began. And that was adapted to San Jose to build a giant corporation called Cisco. Then it became a leader today in the world. But a few decades ago, Cisco was up for sale. In my career, I've seen this, I've been a part of this evolution. And large American corporates were offered a document showing Cisco's strength in a potential marketplace to build a billion-dollar company. And they didn't buy it. They said, what is this router? Maybe we can sell a few thousand around the world. And there's not enough market for us, not enough to invest and waste our time. They passed the opportunity. And you now know what they passed. Cisco is a global leader in networking, routing, switching, which is my space, so I know this game well. Same is the case with mobile telephony. Mobile telephony was invented in Bell Labs. Many of you may not know a company which does not exist today called AT&T, American Telephone and Telegraph. So Professor John Mitchell can add on, we are leading on to each other. So the key is that AT&T Bell Labs invented mobile telephony. And then their own management, which is world's largest telecom company at that time. Their management in their wisdom decided that in order to put in repeater towers around the country, for you to be able to talk on the phone while you're moving about, is a very far-fetched idea and a very capital-intensive business, and it's not likely to be successful, and they didn't take it beyond their labs. AT&T Bell Labs invented mobile telephony, and it kind of stays in the archives of Bell Labs. Now you know how mobile telephony is spread around the world, from Bell Labs' invention to people who are making billions of dollars offering products and services. So what I'm trying to say here is that people have to adapt. As a learned man said, change is the only constant. I made my opening remarks to continue where Professor Baruch said to lead on to what I wanted to speak today about. change. Change is the only concept. Those individuals and organizations who don't adapt to change will fade away. I've seen the examples now. IBM is converted from hardware company to software company today. It's one of the world's largest software companies. And other companies that were in the businesses that they didn't adapt to change, like Sony in mobile telephony, or Bell Labs in mobile phones, and Xerox Corporation into the Icon interface, and all of that stories you can see our digital research and taking their DOS to marketplace. They didn't adapt to the change that's happening in the marketplace, in the names of the clients, the users, and then they faded away. So what is happening today is a change in the higher education space, which is what I want to talk about to lead into my point of discussion today, is a change in higher education is imminent, is happening, is waiting to happen. It has started a couple of years ago, and people are not noticing. And those who don't adapt to it will fade away, like these companies I talked about. So what is the change? The change is technologies have changed. Users have changed, consumers have changed, products have changed, services have changed. You're no longer buying a product by going to a store. You're buying your products online and getting delivered to you, perhaps the lowest price at the most efficient way. Your meal is getting delivered to you. Your groceries is getting delivered to you. Medicines are getting delivered to you. Your consumer goods are getting delivered to you. This is a huge transformation online. The way we live has changed. The way we work has changed. Thanks to the pandemic, work from home has become a very popular thing that is finding difficult to go back to work, to in the office. People want to continue from work from home, even if it's fewer hours in a day. So this change is happening in our society around the world. And this change has also transformed higher education space. The way it's transformed higher education space is the verticals that we're used to so far, arts, science, humanities, engineering, management, law, they're beginning to blur. The silos don't exist. The interface between these disciplines are merged, are going to merge. We've listened to Professor Mitchell, who's an expert in this field, to talk more about it. But the key is that we need to understand that this change is happening here and now. And if you don't adapt it, education, whether it's school or education, higher education institutions, those institutions are going to fade away. So what I want to urge is every educator in the country have to adapt to it. We started Sai University with the concept of multidisciplinary, interdisciplinary education 2018. Sai University was founded in 2018. And I'm so happy to see that the National New Education Policy, which came in 2020, 2 years later, have completely adopted this model of multidisciplinary, interdisciplinary education in their recommendation to the Government of India. So we're happy to see that we've been endorsed by a government-funded organization which has studied the country's higher education space and recommended multidisciplinary, interdisciplinary education as the way forward for all over the country. So that shows that we're in the right path. Second, in 2020, we're talking about newer forms of delivery of education, thanks to the pandemic. And when that happened, we are in the forerunners again, because we prepare for this delivery. With our faculty being international faculty around the world. We see that it has been adapted nationally to deliver programs from the faculty residences to students' residence. The way education is delivered and consumed has become almost like an online transaction that we do with any online trading space. Knowledge provider and knowledge seeker are bridged across by network. And the third change that has happened is recent, last couple of weeks, or was it last week? The government of India has announced a policy, welcome foreign universities or international universities of high reputation to start operations in India. And they've said one of the conditions is that these universities should bring in international educators to India to stay and teach. This is what we've been doing from 2020. So they have now reinvented our policy again 2 years later in 2022. So I'm very happy to see that the government is following us instead of our following the government, sir. Thanks to Professor Barucha and our eminent International Advisory Committee, including Professor Mitchell, who are guiding us setting this academic curriculum and program, that we find, although we are a new university, we are a front runner in this emerging education space. That what we did 2 years ago, the government is following 2 years later. So it gives me a feeling that we are on the right track. So that space I want to say that the Sai University, in addition to these directions, has also made changes in the way the university is structured in India. We recognize that there are 5 pillars of an institution. One is governance. Second is faculty. Third is curriculum. Fourth is infrastructure. Fifth are the students. I'm not putting a priority, but I'm putting a sequence of events. No. And I'm happy to say out of our 18 board members of Sai University's governing board, itself has a multidisciplinary component. We have people from business, people from international universities, we have people from law, people from academics, people from consulting, people from healthcare, every other sector in our governing board to give us guidance on running the university in a multidisciplinary way. We have people from foreign universities, we have people from Indian universities, people from other fields, from healthcare, from law, from scientists, education policy makers, government officials, all of them. Out of the 18 board members, I'm happy to say 4 are Padma Vibhushan awardees, second highest civilian award in the country, and 1 is Padma Shri. Chief Justice Venkatachalaya, Mr. Narayan Murthy, Professor Anil Kakodkar, and Professor Kasturangan are all Padma Vibhushan recipients. And of course, Mr. Mohandas Pai, running 3 universities around India, 2 in India, 1 abroad, as a Padma Shri awardee. They are guiding the governing body. The governing body of Sai University is so reputed that we have a very knowledgeable and experienced governing body. And second is the faculty, which is perhaps the most eminent faculty in the country. In addition to the most eminent governing body, we have the most eminent faculty. 30% of our faculty are international professors from multiple universities. We structured a design that instead of a student going abroad to study in one university, in one discipline maybe where the university is well known, we in fact bringing to Sai University experts from multiple universities to come to Sai University so that the students get the benefit of the experts of multiple universities and multiple disciplines in India itself. And the remaining 70% of our faculty, almost all of them have an international PhD and have worked or taught or researched in universities abroad. So that's the second pillar. The third pillar is the multidisciplinary, interdisciplinary concept of Sai University. That has been spoken enough, and so I don't want to elaborate. But I want to tell you a few things to say that a student at Sai University doesn't have to study one packaged program, physics, chemistry, mathematics, or economics, psychology, and statistics. It is not the case. A student is allowed to pick and choose. A student in the first year is given a wide variety of subjects under the foundation courses. And in the second year, they are selecting majors and minors across disciplines. So we have a student in biotech with a minor in computer science and law. We have a student in computer science with minors in music and law. We have students of diverse backgrounds like that. Because we have 3 schools today: School of Arts and Sciences, School of Computer Science, Computing and Data Sciences, and School of Law. So the students are able to study across these schools any subject of their choice. And in the future years, we plan to add 4 more schools as we evolve. We will be establishing a business school with UG and PG in business. We'll be establishing a school in technology and engineering. We're not planning to go in the traditional schools of engineering, but we're planning to go into newer branches of engineering like space sciences, nuclear sciences, defense sciences, because we know that near generation, all of you will soon be not only be in space, you may be landing on Moon or Mars. So you need to be equipped for that development in our society. So we're going to have engineering will soon have multiple new disciplines this country has not seen so far. I'm not putting a timeline because there are lots of work to be done in terms of getting permissions and infrastructure to go ahead with it. And we're also planning to build a 300-bed hospital and also open a school of health sciences. So in the near future, you will see a medical professional with a minor in computer science, a doctor with a minor in computer science and a minor in law, and a new branch of medicine will emerge. So this is what is the curriculum of Sai University, which we believe is liberal education. We know that there are a couple of leading universities in India, very good universities, who have specialized in liberal arts. But Sai University is not a liberal arts university, it's a liberal education university. We are right now having education across art, science, technology and law, and soon we will have the other branches which I already talked about. So that gives us the flexibility of curriculum to say that a student at Sai University can study any subject of their choice, not as what's given to them as a package or what is forced on them, but what they actually like. The 4th pillar is the infrastructure. As you all know, we have 103-acre campus on OMR. The hardest part in India is creating the infrastructure, because brick and mortar in India is not developed to a stage where we can put up a building in 3 months like you could do in US, stack up 100 floors in a few months. It does take a lot of handicraft work in India to put up a building. So we are having long-term plans to develop the campus into almost 2.5 million square feet of construction. The plans are like in the next 10 years. So we will see that happen, because we also have to moderate in evolution of technology. The way VR and AR, many of you would have heard of VR and AR technology, the way the VR and AR are emerging, they're going to have an impact on the higher education space that you could listen to Professor Mitchell in a 3-dimensional form from Stanford without him having to come visit us in Chennai. So I'm sure that this is going to change the physical infrastructure, and we will keep in track with the physical infrastructure. And the last but not the least, and perhaps the most important of all of these, are our dear students. Therefore, we select students not based on their grades. As Professor Bruce said, grade is just one parameter for us. We judge the students based on 5 parameters, which is the grades. Second is the statement of purpose. Third is a testimonial from the institution where they've done the schooling. And fourth is their common test, any test they've taken to understand their general aptitude. And fifth is the faculty interaction to see if they fit into a liberal education model. So these 5 pillars based on which the university is built is the strong foundation we're laying for the future of Sai University. And we believe that this will lead into a paradigm where higher education in India will be transformed, and like the way the government is following us, we sincerely hope many of the other leading institutions in this country will also follow us, because that will be good for not only the students, but it will be good for the institutions themselves. Because change is the only constant. Unless we change, we'll fade away. The Sai University has been established with this concept that is emerging around the world to provide interdisciplinary, multidisciplinary education, and that people are not going to be controlled into thinking on preconceived notions of packaged education. With those words, I think I want to let you believe that this is one small step for Sai University, but I'm sure there's going to be a giant leap for higher education in India in the years to come. We all look forward to it. Thank you very much.
I'll be brief in my introduction of Professor John Mitchell. He was an undergraduate at Stanford, where he majored in mathematics. Yesterday I asked him why he chose mathematics. He said, because it was so easy, I would have a lot of time on my hands. At which point I said, well, maybe that's why I did not major in mathematics. It was too easy. Just a joke, of course. And then he got a PhD at MIT. Computer science was still in a formative stage as a discipline. You know, as you know, there was a lot of questions. Is it really a branch of mathematics? Is it a branch of electrical engineering? And after that, he went to Bell Labs. He may have had a few other things in between, but Mr. Ramani mentioned Bell Labs, which at the time probably had more Nobel laureates than any university in the world. Yeah. Unfortunately, those days are gone when a big for-profit company actually invests in research that unfortunately is no longer the case. And after being there for 4 years, he joined the faculty at Stanford and has been there, I think, ever since. Has many books and articles to his name. You can find that all online. His work has covered a number of subfields, programming languages, cybersecurity. Students know he's a leading expert on blockchain and its applications. And other areas as well. As importantly, he was invited by the Stanford president to become the first vice provost for teaching and learning, when indicating the importance given by this high-powered research university to the process of teaching. And as some of you may know, in education circles, we've started talking less about teaching and more about learning, because it's really, do it well is less about how we teach and more about understanding how students learn. and adapting our teaching to that. And in that position, he actually was a pioneer in bringing computing into education. And of course, being in the heart of Silicon Valley, a lot of the early experiments with online courses actually started with John and some of his undergraduate students at Stanford. And you've heard of some of the big companies, Coursera, edX. He had a lot to do with the many of these companies. He also has a joint appointment at Stanford in the Graduate School of Education. So speak of interdisciplinary, you know, Stanford Graduate School of Education is visionary enough to bring people from who are not just in the profession of education, but from different disciplines to try to understand and create a future of education. Needless to say, he's been involved with entrepreneurship in many ways. Has many former students who have been successful entrepreneurs, many who are in major positions back here in India. And he is, as you know, those who've come to know him, very humble, very down-to-earth person, very accessible. And we are absolutely delighted to have him as a visiting professor at Sai University and a member of our International Advisory Board and our Board of Studies for the School of Computing and Data Science. Please welcome Professor John C. Mitchell.
All right. I think I have some slides here. There's probably some way to display some of them if we're lucky. See if we can get, yes? Go ahead. See if we get the technology to work and then follow from there, I guess. There we go. Okay. I'm going to talk with you about computer and data science and where they appear in the world today. If you go to the next slide, I guess I've already been introduced. Click the next thing, please. There we go. Okay. So I think the other thing that I was going to add here is you don't have to be that old to see the world change in computing, and we've heard a little bit about that already this morning. In the time I've been a computer scientist, we went from mainframe computing, where a computer took kind of the size of this front section of this room to put a computer, to is the thing you can carry in your pocket. The internet was invented. I remember I worked at Bell Labs when the internet was becoming a buzzword and a concept. And the people that I worked with at Bell Labs said, what? That's nothing new. We've always had computers that could phone each other and make phone calls between them. What's this internet thing? It's not going to make very much difference. As they were not correct about that. And AI, artificial intelligence, was a kind of a fringe subject, an aspiration, you know, a few decades ago, and now it's everywhere. So if you go forward, I think it's clear that, next slide please, computing is now everywhere. So here's a few illustrations. We're making headway in medicine, radiology, scanning an X-ray. It's a difficult thing for a human to do. Computer with computer vision, pattern recognition, machine learning methods can also do things that are difficult for humans. And I think the best path forward is not, will the computer replace the doctor, but can the doctor with a sophisticated algorithm do better than the doctor without that? Because the computational process is going to be relatively inexpensive to produce relative to, you know, educating doctors and paying people to be in the hospitals and so on. Some of our cars are getting smarter. Self-driving cars are on their way, and it's a few years away before you tell your car where you want to go and it gets you there safely, especially in India traffic. I think that's a few years ahead. But the things that are part of developing self-driving cars are going to make driving safer for everybody as we go along the way. Lower picture is something about sustainability. I think a lot of challenges in sustainability are going to be best addressed through computation. How do we allocate resources efficiently? How do we discover weather patterns? How do we solve problems that are part of sustainability? And then the last picture here has to do with Bitcoin or blockchain and new forms of digital currency, which you know, there are some ups and downs there, but I think there's a promising technology, and something will change in the financial system as a result of that. So if you go to the next slide, please. I'll just tell you straight out what my main thought is or main point is, and then I'll have some illustrations. Could you hit the next slide, please? Thanks. I think computing and data science are immensely complex, fascinating, and rapidly changing fields. So I think one of the reasons that students, young people go into computing is it's just a fascinating subject. I think there are skeptics who think, well, we're only going into this topic because of jobs, because it's financially promising, but it really is an interesting field. So I don't want to I don't know where that, turn that down a little bit there. And also, over the past several decades, the science and engineering required to design and build computing systems has become more mature. We've learned how to do the basics of design the next computer, design the next computer architecture, design the circuits that go into it, the hardware, build better software. We've been at that for several decades and we've gotten fairly good at it. So those are relatively mature topics. And I think going forward in the next few decades, and who could predict longer than that, you know, the advances in computing and data science that benefit humanity are helpful to all of us and, you know, make money, because that's how you make money, is solve someone's problem, will come from interdisciplinary collaboration. There's a kind of a tag phrase here, CS plus X, that's popularized by some in our department and elsewhere, computer science plus something else. And we worked hard first to build a CS plus X major, so you could major in computer science plus music was the first one that we tried, and a few other fields. What we've really been most successful at in our department is the co-terminal master's program, where people take computer science, they major in one subject, and then they can get a master's degree in computer science. And if you look at what students at Stanford are doing, about half of the co-terminal master's students are computer science majors, and the other half are from every possible major you can imagine. You know, we have religious studies majors who are also getting a master's in computer science, political science majors who are also getting a master's in computer science. And I think that phenomenon, just looking at the count there, reflects the view that students at our institution, where this is an option, really believe firmly in the value of one field that they're really interested in, combined with computing as a tool and a method for making a difference in their field. And just to kind of summarize a little bit about this, if you move to the next slide, I think that these numbers 20 and 80 are just totally a guess. But I think if I look at the activity going on in my department, when I started 30 years ago at Stanford, we were mostly about how to build a computer. And almost everyone in the computer science department was interested in software or hardware or networking or something about building a computer system. And now that's become mature, and most of the interest is in how do we solve a problem, how do we do something better, how do we change the financial system, how do we learn to do sophisticated things for self-driving cars or for other information processing, other things. And I'm guessing roughly You know, could be 4-to-1, could be 5-to-1, I could be off by a bit. But the opportunities and the progress that we're going to see in the next few decades is really going to be in this interdisciplinary CS plus X area. I have a few slides just to kind of stick up for my field. Can you go to the next one, please? So really, computing is immensely complicated. If you think about what goes into a computer, the hardware, the software, how things work, it's an immensely complicated, sophisticated thing. An order of magnitude, 2 orders of magnitude more complicated than almost any other kind of human artifact. So there's no question this is fascinating and exciting, and if you like complexity and being confused and trying to resolve your confusion, it's a great subject. Next one, please. The way that computers talk to each other. How can I, you know, pull my phone out of my pocket, click, you know, touch a few things, and suddenly I'm connected to the hotel network and I can talk to things all over the world. How does that work? It's an immensely complicated, sophisticated system. So there will always be needs to make that work better, to accommodate new kinds of devices, to be faster, to be cheaper, and so on. Next slide, please. Data science, we have more and more data from more and more activities, understanding what that data means, processing it, very complicated, sophisticated area. And the last one, please. Next slide. This is a very simple example of a neural net from machine learning, building a machine learning model that tells you something interesting, that can recognize cats and tell them from dogs in pictures. That's also very complicated and fascinating and interesting. So all of these areas are sophisticated, complicated, demanding, intellectually challenging, and there's room for progress going forward in all of these areas. Next slide, please. But what's really happening in my field, in our field now, is this kind of feedback loop. We have over time increasingly been able to produce faster computers that store more data more cheaply. So the hardware, the software, the system itself has gotten better, you know, every year for decades and decades. What that does is allow you to do more with it. So people figure out new ways to think about computing, new ways to apply it to new problems, new ways to structure software, new ways to structure hardware, you know, GPUs, graphic processing units, specialized computing, not that old. Lots of new things are available with GPUs. Machine learning was not the driving application for this graphics processor, but that allows us to do faster machine learning, great advance. So as we get better computers and think of new ways to use them, we can use them in more applications, in more areas for more things. And then that gives us more data in digital form, because the more you put computers in your car or in your refrigerator, in your home, in an airplane, different in a hospital, in a school, the more information we're able to collect. And then now that we have more information, we can do more with machine learning, data science to make sense of that information and provide it as input to a computational process, which is now back at the top of the cycle. So better computing makes it possible to do more applications. More applications mean we can use the computers more effectively, and therefore we want more computing hardware. Next slide, please. This piece of this on the left is kind of what's called the AI revolution, the fact that we now can do so much by artificial intelligence, by machine learning models, is really a result of getting out into the world with computing, collecting more information, addressing more complicated problems that matter to people, and improving the sophistication of machine learning models as a result of having all of this data from human behavior on social networks, pictures in digital form, text you can apply, natural language processing, all those kind of things have driven the process and enabled the process in AI, which has led to increasingly more demand for computing. So that's kind of, I don't see this slowing down or going away. We're on a roll here as far as using digital processing for many, many kinds of things. I'd like to tell you 7 or 8 stories about people who've done specific interesting things using computing and addressing something else. I thought that would be the simplest way to kind of look at how CS plus X works in the world, where some challenges are, but also where there's been success to kind of help us all think through what could happen in the future. So can you go to the next slide? This is my friend and colleague, Pat Hanrahan. Pat Hanrahan works in computer graphics. He's won 2 Academy Awards. These are the awards called Oscars, given by the Motion Picture Academy. Normally, Oscars go to actors and actresses and film directors. There are also Oscars for other kinds of contributions to films. So one Oscar for his contribution to the Jurassic Park movie a couple decades ago, but people getting attacked by dinosaurs in a jungle. There were really no dinosaurs. There was a jungle in Costa Rica, but the dinosaurs were added by computer graphics. And another kind of summary Oscar a decade later for contributions to film. So here's a person who worked with computing, got interested in film, made huge contributions there, and in the process also did great computer science. Pat was also the recipient 3 and a half years ago, for the Turing Award, which is the kind of Nobel Prize equivalent in computing, for his foundational work in computer graphics. So I like this example as, it's not really an either or. You can do great science and have great contributions to the arts and other fields. Next example, please. Yeah, thanks. This is Camille Utterbach, who is an artist. She works primarily with interactive art. Here's a picture of an installation in an art museum of something where a viewer, if you go visit the museum, you can wave at the picture on the wall, and the picture changes in response to human activity there. She's been a popular artist. She's had more than 50 shows, worldwide, and including being featured in the National Portrait Gallery in the US and the Smithsonian Art Museum. So great art using computing. I have a third arts example. If you go to the next slide, please. This is now something anybody can try. We do have computer-generated art, and it's a controversial thing. I remember going once when my daughter was in high school to talk to the art teacher at parent back to school night to find out, what's my daughter doing in all of her different classes. One of the things we did was they'll visit the art teacher, and she was doing pottery at the time. And the art teacher said, art conveys a message that is understood by the viewer. That was kind of his definition of art, which I thought was a nice characterization of art. So what is the message and what's being conveyed if the sender of the message is a computer algorithm? That kind of runs counter to this notion of what is art. But it's interesting. So here you can all try DALL-E. It's online, you can type in any prompt, you get a picture generated automatically by machine learning. I started out with a bird landing on a cactus in Tucson, Arizona, to see what DALL-E would produce. And the reason I chose Tucson was I was in Tucson at the time. My father is also a big bird watcher and lives in Tucson part of the year. So I had an expert to consult. And the first Dali picture looked like this. There were 4 pictures of a cactus. It's a saguaro cactus, which is distinct to the Sonoran Desert, where Tucson is. So the algorithm got the right kind of cactus, but it had the wrong kind of bird. It had a bird that doesn't live in Tucson landing on a cactus. So then I recrafted my prompt and said, please draw a cactus wren, a bird that I know lives in the cactus region, landing on a cactus. And these 4 pictures look pretty close to what you could take with a picture, with a photograph, if you were patient in Tucson. But they're all computer generated. No one of these is taken off the web or the result web search. They're all generated automatically. So we're going to have something that looks like art, or could be art, or a tool to produce art based on machine learning and image processing. And I encourage you all to play with this. This is really fun thing to do. Next slide, please. Here's Carolyn Winterer, who's head of the Humanities Center at Stanford. She's specialized in the American history. During the Eisenhower administration, when Dwight Eisenhower was president of the United States, his administration commissioned the production of, I think, 12 historical studies of 12 important historical figures from the early creation of the United States. And as of, so that would be like, let's say 1960, late 1950s, 1960, as of 2010, 50 years later, about half of the work that had been commissioned was completed. So if you say it's taken 50 years to get halfway, it's going to take another 50 years to produce these 12 studies. Couldn't we go faster somehow? That's what Carolyn asked herself, and she said, what could I do with computing that would help move this study, in her case of Benjamin Franklin, forward? So what she did was look at the envelopes of letters sent to and from Benjamin Franklin. Who was the sender? Who was the receiver? What year was it sent? And so on, to look at his correspondence at different points in his life. And these 2 pictures show one of their very simple things. At one point in his life, he was focused on interaction, work in Europe. So the lower picture shows lots of letters back and forth with other people in Europe. At another point in his career, he was in Europe, but he was focused on issues between European-US relations. And there's more in her study. I'd let you look into it or other things like it if you want. But I just took this as a nice example of someone who's primarily a historian, trying to use computing in her work to move faster than, and get different kinds of information and insights than you might using traditional library methods there. Next slide, please. This is Duncan Watts, who among many other people have done studies of how people communicate in online communication platforms. This was, I think, a model there of trying to look at how communication spreads on Twitter. We've all heard the phrase, something has gone viral. This picture has gone viral, this meme has gone viral, this image has gone viral. He was trying to study, does virality really exist? When something becomes popular, is it because one person sent it to their friend, that person sent it to another friend, that person sent it to another, or is there another mechanism? And what he actually found is virality is a little bit, doesn't seem to occur as frequently as you might hear. And when something really spreads heavily on social media, it's typically that one or two people or organizations who basically act as broadcast media, have picked it up and sent it. So I thought that was an interesting insight, that what we use and think intuitively as the way information proceeds on social media is not actually borne out by the data. And the data says really broadcast communication still is the prevalent means on Twitter. Next slide. A couple of examples from biosciences. This is Sebastian Thrun. He and his team in 2017 were kind of at the head of the curve on this. Decided to look at whether a machine learning algorithm using a picture from a cell phone camera could diagnose skin cancer. Fairly complex problem for each of a number of different kinds of conditions shown in the picture. You know, there are two things. One is problematic, and the other is benign. Telling the difference between one and the other is complicated. His machine learning algorithm was able to do as well as medical experts seeing the skin in person. And that kind of opened up a line of work pursued by many people in radiology and looking at other kinds of medical imaging. The schematic on the left is really a kind of diagram that says there's some order, there's some taxonomy of different kind of skin conditions. And that was another input here. But I thought it was a nice example of using computing for solving a medical problem. The next slide, please, is Ron Dror. Work that was featured in Science magazine on understanding molecular structure in the form needed for drug design. So drug design is a hugely complicated process. It's a little bit hit or miss, and then people hypothesize that a certain kind of molecule will be successful in binding to a virus. Let's say if you had an epidemic and you had to create a vaccine, you'd have to find something. Typical mechanism would find something that binds to that. And this is another use of machine learning to look at molecular structure and improve the process of drug design. Another great example of using computing to solve a problem outside of computing. And in all these cases, I'm showing one person who has an expertise either in computing or another field, but these are typically collaborative processes. This paper by Ron Dror has 6 or 7 authors with bringing together different kinds of expertise. And finally, I thought I'd give an example from computing and law. Turn the next slide, please. I think one of the biggest problems with cryptocurrency is the lack of regulation. This is an area where tech people have created the tech industry. A few groups have created alternatives to traditional cash and monetary instruments. I think the idea that you could just create another form of money and not have any fiscal policy, monetary policy, any of the accepted things that we do now to stabilize currency and make it work well, that's probably unrealistic. We're going to need some kind of structure around new kinds of money that are similar to structure that we had around old kinds of money, because that structure exists for a reason. Might not have to be exactly the same, but we'll need some things. So this is Joe Grunfest, who's a lawyer, former member of the Security Exchange Commission in the US, and one of the leading authorities on regulation for cryptocurrency. And if you look at recent stories around success and most recently failure in cryptocurrency, I think it's largely attributable to lack of regulation and legal issues, things that would be best solved by legal means. And I think we would have all done better in that area if there had been greater collaboration with lawyers and with government along that path, or at least that's something that's going to be needed in the future. So I hope these are useful, just simple examples of problems and areas and accomplishments that are not solely about computing, not solely about another topic area, but really bring together the two topics. And there are indications that there are many good and interesting problems ahead that are computing and something else. So I think the next slide is just kind of my summary kind of position or view on this, that first we acknowledge computing and data science are really interesting fields in and of themselves. But much of those fields are relatively stable and mature. And what's going to be most exciting in the next few decades, by and large, are going to be examples, topics, problem areas, advances like the ones I've just summarized, where we're using computing and data science to address a complicated problem that's important. And progress will come not just by having expertise in computing, but by teaming up between computational and data science experts with people who understand medicine, law, humanities, arts, sustainability problems, and so on. And I would encourage anyone who's studying in this area to, dig in, understand the aspects of computing that interest you, but also learn about something else so that you have a goal in life, you have a way to connect with other people, you have a way to use the tools that come from computing and data science to address something important and to talk with other people who have expertise beyond that field. Okay, so thank you. Those are
Any big questions? No. I think the floor is open for questions.
Sure.
Is there a mic that can be passed around?
Be happy to answer questions, and if I can't answer them, I'll pass them to somebody else. Okay. Any thoughts?
Yes, please stand up, give your name. Where's the mic?
Good morning, sir. My name is Bharat. I'm from Sai University, the School of Arts and Sciences. Hello?
Yeah.
Yeah, sorry. So one of my questions would be down the lines of computer sciences, but rather more than the application part, we have a... Can I not use the mic? I'll try my best to be as loud as possible. Yeah. So my question was more on the post the applied part. So for example, in our college, we have a course called Global Challenges, and this time our paper that we wrote, the submission was about the ethics in politics in a given space of our choice. So we spoke about computer science. You spoke about the last example you gave was on law and the SEBI, the Security Exchange Board. Assuming that case, taking that case in point, what would the ethical considerations be in that field of applying computer science to such a field?
Yeah, so that's I'll try to think a little bit about that particular example, but also, ethics more generally. I think it's a complicated topic. I think the simplest thing to consider, advocate, move towards is more understanding in the development of a technology of what its impact might be. Because without any understanding of the impact, it's difficult to make ethical or other decisions about what would be the responsible thing to do. So one big problem area is that prediction part. And I think there's no simple solution, but it's kind of a design thinking challenge in my mind. If you're going to build a new device or a new technology, how will it be used? You can hypothesize things, you can interview with people, you can run case studies, you can try to get more sophisticated about it. And then try to make decisions that you're comfortable with as a designer. This is an area where in my department we've put a fair amount of effort over the last couple of years. There's a book by Mehran Sahami, who's in our department, and two people who are, one a political scientist and another a philosopher around ethics. And following on from that, what we did was hire somebody, bring in somebody who's an expert in technology ethics to help build, as components of different computer science courses, a piece of that course that looks at ethical issues and helps students in that course become more sophisticated about that. It's really, I think, there's no easy answer to this question. I do think that design with some understanding of impact, is an important part of this. It's not just about, some people have advocated that computer scientists should know when to say no. And think of it ethics as kind of a whistleblower or naysayer kind of thing. And I don't think that that's the whole story. I think it's really more important to think about what are you trying to do, how can you make that part of your technology, and how can you be alert and aware of possible unintended consequences so that it's not a surprise, and then try to make sensible decisions. Yes.
I said, can we hear your views on computer science in the emerging fields of artificial intelligence, robotics?
Right. So so one thing, robotics is kind of mechanical engineering and computing, put together. There's the robotic device, which is a mechanical thing, and then the control of that is really a part of computer science. Machine learning, the part of this that I'm most aware of is really using machine learning to have more sophisticated and interesting behavior among robots. I think the current state of the art is that robotic control with one kind of sensor is understood to a certain degree, but there's a new frontier around multiple sensors. So if you try to pick up something by touch or position, that's one kind of problem. If you try to pick up something using vision, that's another. Current state of the art is, can I combine those two kinds of inputs to do more sophisticated things? That field seems to be booming. There seem to be lots of progress in the area of robotics for specific kinds of tasks. It seems like a very, very promising area. I'm not sure what else to comment on it, other than we have so many quick breakthroughs recently in artificial intelligence. If you haven't followed this, one is this DALL-E program, which was just made publicly available within the last 6 months or so. There's another one, ChatGPT, which is a language conversing program. These are just very substantially different from what was available a year ago. That seems to be a very, very rapidly changing area. In those cases, vision and language, I think robotics then follows and has similar progress. One easy thing to say is this is not the end of it. We don't know whether we've seen the most sophisticated things in the most recent vision and natural language AI. I think most experts and most people connected with it would say, no, we've just made breakthroughs now, and we'll have another breakthrough in a couple of years, and another breakthrough beyond. It's really very challenging from an education standpoint if you assign an essay and a class, and somebody just types the assignment in to an AI program, and that generates an essay, and they turn it in. That's going to be a problematic thing in classes. And I think it's a very, fun, to me, it caused us to reflect on what are we doing in education? How do we get people to think? And when there's a tool that really changes what's possible for someone to do, how do we integrate that into our process? Another way to look at it is, suppose you were a journalist. I talked with a few here. Could you use AI to write your articles? Should you? How can the new tools that write things that look pretty good be used successfully to make people who are writers more efficient and more effective? If you were writing a book, how much of it should you turn over to an AI algorithm? How much of it should you do yourself? How would you balance those things? Very complicated. I'll give one example, then I'll take another question. My friend Andrew Ng, who's at the leader in machine learning and artificial intelligence, asked GPT-3, this language model, to explain why abacus computing is better than GPU computing. And it's totally preposterous. The answer is a reason why using an abacus, which if anybody uses it is a bunch of beads on that you move with your hands, why abacus computing is better than an electronic computer. So I thought that was a really interesting example. Most of the examples I've seen using this machine learning models to write a paragraph or write a story start with a very reasonable request that's kind of truthful and accurate to what we know about the world. But if you started with an unreasonable request for something that's incorrect, you might also get a very plausible sounding paragraph or a few paragraphs out, which was a good indication to me of one of the limitations of the method. It really doesn't know anything. It's just trying to put something together that looks similar to other kinds of texts that it's found online. Another view, I think, which maybe you've heard, is you can think of these language models or this kind of vision model as a different kind of web search, because that model is based on a lot of data. The data is generally gotten by crawling the web. Our traditional form of web search is like Google. You type in a query and you get a page that somebody wrote. This is another way of typing in a query and getting an amalgam of things that many people wrote. If you think of it as another kind of web search, I think it's a powerful tool, and we're really at the beginning of understanding what we can do with that and how do we use that effectively. And with similar questions came up in the early days of the web. Were students in school going to turn in papers that they found by web search instead?
John,
Yeah.
smart contracts. I've heard you talk about smart contracts. Could you talk a little bit about what fields and professions are likely to be impacted by the emergence of smart contracts and what a smart contract is?
Sure. So a smart contract as a concept is typically it's a program that's written into a blockchain as a form of agreement. And an example might be, a simple example would be a loan contract. So I want to borrow some money from you. So our smart contract is you pay me that money that I'm borrowing, and then I make monthly payments back to you to repay the loan. That is a kind of simple agreement where we understand the terms and their conventions about loans and repayment and interest. You could also put other kinds of processes, the steps that are used to buy a piece of real estate and have it inspected. You could have the steps that are used to complete a process written in a smart contract, and then that would be, instead of a piece of paper that people have to follow directions to, it's a computer program reflecting an agreement that automatically does some of the steps as a result of computation. So I think like many kinds of computational progress, this will start with the simple things, the loans, but they could become parts of much more complicated financial instruments, arbitrage, things that are done by hedge funds or something like that. And this could go into many other different lines. Do you have anything else specifically in mind that?
No, I'm just, given the topic today, people are thinking about different professions.
Right.
It sounds to me that the emergence of smart contracts could disrupt a number of different professions, including law and finance, and that people in those professions who are knowledgeable about what's coming with smart contracts might actually be able to be the ones to take the lead.
Sure. I mean, there's a potential in law, I think, and law is a little bit regional. I think things that are done commonly in the U.S. might be different from things that are done commonly here. But there are things you hire a lawyer to do if you start a company or if you're concerned about your will and death, other kinds of things where many of those legal documents would be very similar. And I know there's progress by lawyers on how to make it easier to craft a large number of similar documents. And there's, I'm sure that with machine learning and other methods like that, it will be easier to produce more legal documents effectively. We'll have these oversight problems, just like the issue with asking GPT-3 to say something that's not reasonable. How do you know that something produced is reasonable? But certainly the potential for automation in law is great and something promising.
Any other? Yes, Professor Maya Ranganathan.
Yeah.
So thank you for a very interesting talk. Just had a question. I mean, when you mentioned chat GPT, there were a lot of smiles on students' faces because that is something that we are dealing with. And so the chat GPT kind of set off a bit of a reaction. I noticed a lot of people smiled, and we know that they are using it. And we are also trying to understand how best to kind of find that and try and, the Territon is incorporating it. But that apart, if we are talking about, say, something foundational, because we are talking right now about computer science and the way that it influences these disciplines of arts, sciences, humanities, and law. So in terms of education, if we are talking about a foundational course for students who are enrolled in all these different disciplines or who are hoping to kind of specialize in these, what would you suggest? Should we be focusing, say, on the ethics of it, or on the way it is actually changing the society, the way it is kind of changing the world experience itself, or about the challenges that it poses, the disruptive nature of technology? What really would you think should be the focus of such a course, a foundational course for students?
So one great thing about education and innovation is we can try. There are many schools, there are many teachers. Different people teaching in different schools will have different commitment to different ideas. So I think one answer is try them all. I mean, another suggestion, though, is the first thing I would start with is make sure people are not scared of the technology. And so one thing I've seen is that for many young people, being comfortable with computing and feel like this is something they can create and they can change and control might be a good starting point, some degree of familiarity. And then all of these questions are important. I don't think there's any way to say that one is categorically more important for the other. I would just try to investigate those deep questions as best you can, starting with some degree of understanding so that students working on something feel they have control and some opportunity to make a difference. Okay. So this question, does blockchain involve compromise of privacy? Um, so first, I think from a technical standpoint, blockchain is a way of recording in a visible way a transaction or a piece of information. However, the information that's recorded on a blockchain can be encrypted. So there's nothing inherent about writing something to a blockchain that has to be a violation of privacy. Now there is some traceability in some kinds of cryptocurrency and means to reduce traceability in others. And then an issue that is kind of a trade-off for fraud detection. You know, it's important to have some degree of visibility, and legal frameworks for detecting fraud typically involve, you know, know your customer is a KYC is a term for it, having some understanding of whether who is making the transaction. To give a little bit more of a concrete example, if you were a criminal organization and you wanted to move a lot of money from one country to another, certainly making one big transaction at the time of a drug sale or something like that would trigger some legal investigation. Law enforcement would come after you. So the first thing you'd try to do if you were that criminal organization is break that down into lots of smaller transactions so it would look kind of more like normal business. This know your customer or be able to identify the sender and receiver is a means to try to detect movement of a large amount of money in lots of small pieces and apply the same legal investigation you would apply if there was a large transaction. So that's kind of a framework and a degree of visibility that most legal systems, most countries will require for cryptocurrency. And that gives you some visibility into, there's some loss of privacy in that fundamentally. The same thing would be applied if you were moving money by any other kind of bank transfer. So it's not a loss with blockchain, but it's something different from actually, you know, moving wads of paper money there. Is that helpful? Okay.
Thank you, sir.
So hi, I had a question based off of ChatGPT and Dolly. So I feel like it's fair to say that when you're looking at interdisciplinary fields, the main purpose is to make ease and access of information and knowledge more common among the people and make our lives easier. However, when you look at things like Dolly and ChatGPT, not only does it take away the human expression factor of art, research, and gaining of knowledge, it also actively impedes on jobs of people in these factors by making writing or making art something that can be done even by machine. And it also actively, it adds barriers on human experience and human gaining of knowledge. So I was wondering, in some ways it does of course make factors such as art without any actual royalty put on it, or stealing art. It cancels this out of the equation. It takes away factors such as struggling for writers who need information fast. However, do you feel that these aspects take away from ethics? And does this seem like an issue that needs to be covered in the future of creating these softwares? Or do you think that the ready accessibility and ease of this information will be more prioritized in the future?
Great question. I think the first thing that comes to mind is I'm very glad that OpenAI has made these things available for free to all of us on an experimental basis. And I think that that's really the most responsible thing they could have done, is let everyone try these things out and wrestle with the kind of questions that you ask. I don't think it's possible now to give an answer to that. I think, but fortunately, we all have the ability to experiment with these tools and come to some understanding of these things and see what we think is really responsible. This might seem a little bit far-fetched, but when I was in school as a young person, we used to have spelling competitions. And it was considered really important to know how to spell all the words. You now can use a spell checker and it will correct your spelling. Sometimes it corrects your spelling to the wrong word. So you have to, as an intelligent person, decide whether the output of that spell checker is correct in what you want to say. But I would never try to write a paper or a document with spell checking turned off, because it just, as an algorithm and an automated method, helps me produce a correctly spelled, correctly written document more effectively. And it could be, very possibly, 3 years, 5 years from now, we will see these AI tools similarly. We'll understand what they can and can't do, and maybe we'll become more sophisticated viewers of art or readers of text, so that the automatically generated news article will not be, won't get any traction. Nobody will want to read that. We'll all want something that has some human thought in it. There really is, I think, no way to go backwards in time. You can't, whatever the advantages and disadvantages of this technological advances are, we're going to have to live with that. So people are going to continue to produce more sophisticated machine learning models for vision, for language, for other things too. And so this is part of the rapidly evolving world we're all going to live in. And the best thing we can do is try to understand the new technology in ways that let us make sensible decisions about things like employment, ethical construction and use of things, and so on.
I have a follow-up question.
Sure.
Based off of this, in terms of AI and human interaction, and as you say, technology is moving forward and forward, we see examples of arts and human AI interaction, such as you said with Camille Utterback, or with motion sensors in video games. And I was wondering, are there any other fields you would see these interactions in, and what are like the job prospects of this?
Sorry, could you just repeat the last part about the?
I was wondering what are some other fields you'd see this human AI interaction is, and the possible applications of it in science, along with the job prospects, career prospects?
Good. I would guess that in a lot of different kinds of work where there's data that can be applied to an algorithm, there will be some use of tools. It could be in planning, in finance, in projections, let's say. In our department, as recently as department chair, every year we have to project what our expenses will be in different categories. And we have some input from people who are responsible for those areas who they guess, but we're always off in a certain way. So maybe a machine learning algorithm could help us make better predictions on that area. I think there probably are, there's as many different possibilities as there are activities where there's enough data collected that you could see if there are patterns that would let you do prediction. In jobs, I think it's always been the slogan to sort of look for activities that you think can't be automated and think of that as a good potential for a career. Although, to me, it's a little bit hard to predict accurately what's not susceptible to automation. So I would think for career, find something that you're committed to, that you believe in, that involves a cause and a kind of work that's important to you. And then I would assume that for almost all lines of work, there will be some computational tools that might help you. So if you find if you like architecture and building and design, there will be methods and tools that help you with that. It would be probably a poor choice to ignore those because they'll have some impact on how you do your work. But if what you enjoy is the design and construction of building and interior and exterior features and so on, then I mean, as human beings, we will always live in buildings or have, a certain fraction of the population will use built environments for various purposes. So there will be a future there. The nature of the kind of work you do in that future is unknown. So plan for the unknown, focus on the things that are important and meaningful to you, and understand that there will be tools that change the way work occurs.
Thank you.
I have a specific question.
Okay.
This relates partly to our own interest to protect indigenous knowledge and traditions.
Okay.
So I'm Bhavani Shankar, and the question is this. We did try some high school research projects, independent research projects where children were asked to track the non-tangible aspects of heritage, just the ways of life, ethnicity, so my grandmom's recipe, so on and so forth. So these, there are multiple claims and counterclaims. So is there a way that we can use, say, the data that's already available to understand and protect the intellectual property that is primarily determined by the ethnicity of a particular place? So I was wondering if there are tools. So what would those tools be? And would it be possible for us to track from, let's say, the forensic analysis of all the history of the content that's available to protect the interest of a particular ethnic group, so which is only transacted orally, and all the aspects of their heritage have been, to the best, non-tangible and not tangible aspects of their heritage. So how to protect these, if there is a possibility to invite maybe the AI or the computational skills there, so that would be managing biodiversity, so it would definitely protect the intellectual properties, and therefore it could be an interesting interdisciplinary zone. So.
I'm not sure what the solution is. I mean, it seems like a really compelling topic area. The first thing that occurs to me, but there might be other better ideas, is if you have an oral tradition, then capture it in some way. If it's an oral tradition, you're going to capture it orally and preserve that. You might be able to make that more vivid for young people through tools. That might be one promising direction. To hear an explanation of something out of context, or it may be difficult for a young person to process, but if there's a visualization or a way for someone to place themselves in another historical or cultural context and understand that, that might be one idea. This is a little bit not directly on your question, but maybe it's helpful. Virtual reality, we have a collaborator who has done work on virtual reality and empathy. And so if you imagine going into a classroom and everyone looks like you. That's going to be a different experience from walking into a classroom. People look very different. So my colleague has built this kind of simulated virtual classrooms where you wear a headset and you sit down, and he can control what do the people sitting around in a circle or at other tables look like, and how do they behave, and you see yourself superimposed into that, and that provides a lot of insight for people. If you're in a majority group and you're not used to being in a minority, to put you in a classroom where it's just the opposite, is compelling and memorable for people. So I wonder if there's something here around preservation of culture that would involve capturing, in some way recording, but then giving young people who are not deeply immersed in this an empathy building understanding of the culture that's their culture or someone else's culture, so they could appreciate it. Those are the first thoughts. And great question, great direction, and great goal.
Another. I have. I once heard a talk both at the conference from one of your Stanford colleagues on automatic mathematics learning, automatic mathematics tutoring that's customized to each student's unique ability to sort of navigate the problem space. Could you talk a little bit about things that are going on? We have some educators here, and I think many of us who are educators and people who are teachers in schools as well, often the technology is ahead of the methods that we are used to teaching with, but a lot of these things are going to happen. Can you tell us what is kind of on the horizon in terms of automatic tutoring and automatic grading and things like that?
Sure. It's a kind of broad area. The place I'm most familiar with that is in teaching computing, because that's what we do. And we face a problem. Our department is, we're about 2% of the faculty of the university, and we have about 25% of the students. So we are outnumbered 10 to 1 in comparison with other departments and the number of students they have to teach. So we're trying to use something we know about, computing, to solve our own teaching problem. And there are a couple of ways that we're looking at this. One is to try to provide meaningful feedback to someone as they progress through solving a problem. And there are various ways to do that. Typically, you need to understand what's a correct problem-solving solution. You can either do that by sort of introspecting and trying to produce that yourself. I think that's in often cases sort of intractable. But we did do one, I have a research paper on this, which is, I'll try to explain it very concretely with programming. If someone, we assign a problem and we understand what we're trying to test or help someone develop in that problem. And so you can write down there 10 decisions that you think someone has to make in order to solve this problem correctly. And then for each decision, you can say, well, if they made this decision correctly, then their solution should have this characteristic. And if they made that decision incorrectly, then it will have this other look. And if you combine all those, you can generate a large number of possible solutions, each one with the list of things they got right and the list of things they got wrong. Now, if you've done that automatically, that's a big computational task. A student produces a possible solution to the problem, you try to match it up with one of those. Then you can tell them, good job, you got these 3 ideas correct, but we think you've missed this other thing. So go back and rethink your decision about that. So that's, one fairly labor intensive, but something we've tested out and has been effective as a way to provide feedback. Somewhat simpler problem is just grading, but that also is done, I think, best by this similar kind of method. So we're interested in how could you automatically provide feedback? How could you provide assessment? Another area, what we do in our basic computing courses, because we're so outnumbered, is enlist students. So for our beginning computer programming course, we enlist and hire, pay undergraduate students who've completed the course to help us teach it to the younger students. And then we have, on an advantage, a lot of people to help us. A disadvantage is all we know about them is they did this course right once. So we have basically a teacher training problem. And that's another area where tools are very helpful. So for that, what is, a general idea is give someone a simulated student so they could practice teaching over and over again and learn some skills around what kind of feedback to get. We don't really have the fully featured simulated student yet. What we have are, here are a few things that come up. Here are some examples of mistakes students have made. Here, what is your response? And then an automated tool that can tell you that's not really the best response or that is good a response. So a little bit of a framework for learning to be a near-peer instructor has been good. Another area, there's a tool is very widely used in our institution called GradeScope. You can take a look at it. It's a grading tool. It was originally created by graduate students and a faculty member at Berkeley to help them do grading. And what it does is let you, as a human grader, go through a set of assignments or exams turned in by students systematically and define a rubric and apply your grading process individually. To tell you a little bit more about it, normally if you had a paper exam, let's say, turned in, you might have 10 pages. If you're going to grade it, you have to turn page, look at it. If you scan that and put that into GradeScope, you can grade problem 3B for all of the students one after another just by clicking and moving from one student's answer to another. Then when you read that answer to problem 3B, you say, well, that's pretty good. You got this part right, you got that part wrong. We're going to give you, 2/3 credit for it. You could type in that response and paste, kind of cut and paste it into each student. So each student feels like they have gotten a custom, well thought out response, but it's really one of 3 that you've entered into the tool. This framework, which I'd encourage anybody to try if you have a large enough class to make it worthwhile, now leads into possibility for automation. Because we have, for courses we've used GradeScope, several years worth of assignments and grading rubric and how, data on how we've marked different student work and so on. So there's another, kind of beginning of the wedge in to help automate that. And I think there's research at various places that will help with that.
Are those going to be open source, public?
This is a commercial product. It's a product from a bunch of academically minded people. I don't know that there's I don't know what it has been available for free for a number of years. There's probably some university contract that we have that's fairly lightweight. But the company is open, as graduate students, open to people doing research with the data. And so I think it's going to support research that then could be applied to another platform that's it would be great to have an open source one, and there may very well be one at some point. I'll give you another example that now occurs to me, which is plagiarism detection. So this, if there are a few things that are open freely for doing that, if you have students who might copy from one another, you can detect that often fairly well with automated tools.
Yes. Yeah, so Web3 endorses decentralization, but with decentralization, I feel that there comes disorder and increased entropy in the system. We have seen that in many Web3 applications, such as, let's say, Binance or you can say OpenSea. The central claim is decentralization, but in the true sense, it is not decentralized. What would you say are the methods in which true decentralization could be established?
Yeah, sure. Yeah, okay, great. Let's see. You're asking what is centralization and decentralization, and when do they occur? I think let's start with your basic point, which I think is legitimate, which is we talk about different currencies, exchanges, cryptocurrency as decentralized. But then there are these organizations and actors that seem to have control over various aspects of finance in the same way that banks would with traditional currency. Is that your starting point? And so you're saying, what is this decentralization about? And I think it's, maybe it's a way of replacing an organization like a stock exchange with something that's not organized in the same way. So it's a different kind of organization. But I think your point is legitimate, that in this framework, there are actors that act like traditional organizations. Maybe step back though. I mean, the currency would not be successful in the way that is if there was one organization that controlled every Ethereum or Bitcoin transaction. So I think it's at some other lower level that we have the benefit of an ecosystem in which any computer system could potentially be a miner for Bitcoin or Ethereum. And that's the decentralization part of it. I'm not sure that's a very crisp answer, but that's kind of as close as I can come at the moment to your question. Do you want to follow up a little bit, or is that helpful? Further questions?
Thank you for now. Yeah.
Okay, yeah. We can talk later about it, maybe.
Sure.
Thanks.
So my question is more focused upon, is quantum computer science still a topic of research, or we can start innovating in it in the near decade? And has the time come for us, for this generation to actually start building a quantum workforce and start leading the quantum computing industry that is going to come up in the next few decades?
Great question. So if I could predict the future, I'd be glad to do that. Quantum computing is still, I don't think there's been a decrease in academic interest in quantum computing. I think there's been an increase. There's a huge amount of interest from physicists around the creation of quantum computing, what the devices and construction of a quantum computer would look like, how to make that practical and more effective. There is some work in computing science on what algorithms can we do with quantum computing, what problems could we solve if we had a quantum computer. in ways that are better than what we can do with conventional computers. There are companies involved with this. So Google and others have invested in quantum computing. I think that it's still, a long way away before we have practical quantum computing to solve problems that are kind of large enough in examples to be interesting. You can do quantum computing with a small number of bits now, but not more. So it's a technology that sounds promising. People who are experts in the field believe it is more promising now than it was 5 years ago. So presumably, if you extrapolate from that, in 5 years, they'll be even more convinced that we're on the path to something. But it will take some kind of breakthrough to produce large-scale quantum computing that's available to many people. It could be that we will be able to produce a quantum computer that could break some form of cryptography for one particular message, let's say, in a few years. And that's what everyone in the field of cryptography is worried about, is could quantum computing break our crypto system? So that's one focus that gets a fair amount of attention. It's certainly a live topic area with international research and effort on the topic.
So my follow-up question is like, as we have talked earlier in this talk only, that the Steve Jobs has started building, is one of the most successful entrepreneur. He has started building the personal computer revolution in the 1970s. So the personal computer is on the comes on the peak after 2010, when it goes to almost every household throughout the world. So if we predict from now that in the next 30 or 40 years, even the quantum computers could be practicalized. So is it very good start? Is it a good start to start research and innovation in this domain also by leading the future? If your opinion on this.
I guess my guess is it would be, we don't want to assume quantum computing will not advance. There are good, smart people moving forward in that area. They will continue to make progress. When there will be larger scale access to quantum computing, nobody knows. If you'd asked somebody 50 years ago, when will we have a breakthrough in artificial intelligence? They would have said, 2 years from now, 3 years from now, we're just about to be there. But it wasn't until, the last decade that we really had very different progress. So I think it's much harder to predict the timing of change than it is to guess successfully at what might happen. So I think because there are lots of smart people working on this area, people are convinced it's possible to make progress. We will eventually have more successful, lower cost, larger input and output quantum computing. But I wouldn't make any particular bet on this decade or the next decade or the decade after that. I think it's a long term, and somebody else might know more about it. But with that in mind, you have to decide how much time and effort do you want to put into something that then might come to fruition a decade, 2 decades, 3 decades from now. If you're thinking about a personal decision about doing work in the area, I would try to find problems that have some relevance in the meantime. So there are some ideas about different algorithms that operate on a quantum computer. Could progress on that also tell us something about algorithms that run off of this, or different things about the nature of quantum physics or some other area. So maybe that's a little vague, but if you can combine an interest in quantum computing with progress on problems that also have some other value while we're making progress on quantum computing, that's a better, might be a better use of time and resources.
Just wanted to check, as someone who also works with the industry, with the technology industry, do you think there is a need today for the tech industry to hire more arts and humanities people with that background? You know, it's not just jobs in tech for just techies anymore. With Chat GPT and other things kind of coming up, making it more human. Is there need for more arts and humanities jobs in tech? Is that happening already?
I think that you may find interest in companies in hiring people who are sophisticated about the topic area, but not in a way that, but also can be contributors and to the culture of the company and to talk with others there. So my guess is, you know, if you took a large tech company, they would be interested in the expertise around arts, sophistication around ethics, other topics. But if you were looking to be in that career path, you'd also have to be conversant in the other things that happen in the company so that you understand the technology, can talk with your coworkers, and so on. I'm sure there's room for some number of artists. I don't know how to estimate how many. In design, there certainly is, but I think for these computer-generated images, some sophistication about how to look at images and their quality would be a very useful part of that. So that's something that artists would be aware of, and someone coming from other areas of computing might not. So I don't have a simple answer for you. I don't think we're suddenly going to get a massive demand for people who know how to paint, you know, to be hired at tech companies. But maybe people who are sophisticated about visual communication would be more valuable if they also have the technology skills.
I know in the music industry, a lot of well-trained musicians have gone into the computer industry for the obvious reason. I don't know about the visual arts. But I had a follow-up question to the one on quantum computing, and I'm no expert, but I read that China seems to have taken the lead in satellite-based quantum communication. And being an expert on cybersecurity, what I read was quantum communication signals are immune to being decrypted. Is there a fear that China will take the lead in encrypted communication?
A simple answer is yes. You can hope that there would be, maybe here's another angle on it, which is, having worked in that area a little bit, I think that groups of people with open exchange, groups of scientists with open exchange, are generally more productive than secretive groups. So you can hope that as researchers in China make progress, they will feel it's more effective to be, at least some individuals will feel it's more effective to communicate with others and will know a little bit about what's going on. Cryptography did to kind of open create this problem. In the early days of public key cryptography, when cryptography became an academic subject, the US intelligence community really tried to interfere with that. Because up until that point, governments were had control over cryptography, and non-government actors didn't have the ability to send encrypted messages that couldn't be decrypted by the government. We've moved into an era where that's, long gone. If, organized crime agents want to communicate with secure encryption, they can do that. But, we still, the world goes forward and not everything has fallen apart. It could be, I would expect there are conventional cryptographic methods that would let Chinese satellite communicate to Earth in a way that no other government could intercept that message already. So it doesn't seem massively qualitatively different from that standpoint. But it is, no one likes to be left behind on scientific progress. And we don't know exactly what else could happen as a result. The quantum communication is not really interceptable. That's its main advantage, I think. So no large country would like to be left out if that's a potential. Do you have other thoughts about that, or?
No, I'm just,
Yeah.
as an ordinary person, I interpreted that as a sign of concern for.
Yeah, sure.
The United States and the European Union, neither was willing to fund these satellite-based quantum communication experiments, and the Chinese government did.
Yeah, and so you can.
Now they're ahead.
Yeah, and you can bet there are American and European scientists who are going to their governments with this kind of information and saying, let's turn this around. And I'm sure at some point somebody will feel that's important, don't you?
I would invite a student, president of Sai University Student Government, Sneha, to give a vote of thanks to our.
Hello everyone, a warm afternoon to everyone. I'm Sneha from Sai University from the School of Computing and Data Science, here to propose the vote of thanks. I would like to thank Professor Mitchell, Dr. Bhavani Shankar sir from the Sahodaya School Complex, and all the educators present here for your presence and your valuable time. I thank the Chancellor, Mr. K.V. Ramani, the Vice Chancellor, Professor Barucha, Sanjeev sir, and everyone for arranging this wonderful talk. This has really been very informative and interesting on how computer science can be applied to various disciplines. And I really hope that it was helpful to all the students present here. Thank you, Chancellor sir, for explaining how interdisciplinary education and liberal education works at Sai University. And I thank everyone for your wonderful questions, and looking forward to more having interactions with you, sir. Thank you.